So we were on problem number 6 yesterday, and we got through parts A through E. We're taking the point -5, 2 and applying different transformations to that point. So again, this is problem number 6. We got through parts A through E. Now we are ready for part F. Part F says to map point M to point M prime, and then it has this notation here. What is this telling me to do? Left 3, up 7. The first number is always your left-right number. The x-axis goes left and right, so it's telling us what to do in the left-right direction. Second number is the y number, and because it's positive, that means we're going to go up 7. So I've got 2 ways I could approach this problem. I have a graph right here. I could plot my point. Let's look at what that point was again. -5, 2 is my point M. So I could plot -5, 2 on the graph. And then I could count left 3 and up 7. Or I can approach this the way I did part E, the part right before this particular question. We could use the adding and subtracting method. This right here tells me I want to take the x part of my coordinate and I want to -3 from it. So over here where I have this -5 in the x part, we can -3 from that to shift it left 3. Second part right here says y plus 7, so we're going to take the y part of the ordered pair. We're going to add 7 onto it. So I'm going to put plus 7 right here. And I can use that to find my point M prime. Again, you can use the graph if you want to. You can plot the point and then count, or we can use the adding and subtracting method. What is -5 minus 3? -8. And 2 plus 7? 9. So -8, 9 would be my ordered pair for M prime for this transformation. All right, rotating 90 degrees clockwise about the origin. 90 degrees is 1 quadrant. Clockwise, of course, is this direction. I'm going to go ahead and plot the point on my graph so that I know what quadrant we're going to be rotating into. -5, 2 is right here. Here's my point M. It's in the second quadrant. If I go 90 degrees clockwise, that will move me into what quadrant? Yep, into my positive quadrant. When we rotate 90 degrees, we switch and then match the signs. So the first thing I would do is take my ordered pair of -5, 2 and flip it around. So that would become 2, -5. And then we have to match our signs. If we're landing up here in quadrant 1, everybody's positive. So I have to make the 5 a +5. Part H, we're going to rotate 270 degrees about the origin counterclockwise. So 270 degrees would be 3 quadrants. Counterclockwise has us going this way. Well, if I take my point M right here and I go counterclockwise 3 quadrants, it puts me in the positive quadrant. If I flip this ordered pair around and I make everybody positive, I end up with the exact same ordered pair that I did on the previous problem. I would get 2, 5. Remember, 90 degrees clockwise is the same as 270 counterclockwise. And that works the other way around as well. 90 counterclockwise is the same as 270 clockwise. 90 one direction is the same as 270 the other direction. Rotating 180 degrees about the origin. What was our rule for that one? Switch the signs or change the signs. So I'm going to come back to my point M, negative 5, 2. We're going to change both signs. So instead of negative 5, it becomes positive 5. Instead of positive 2, it becomes negative 2. So M prime would be 5, negative 2. And then finally, we get to our last problem here. We want to reflect over the line or across the line y equals negative 4. So y equals negative 4. Go to the y-axis, find negative 4. That's right here. This is a horizontal line because it goes through the y-axis. So there's y equals negative 4. To reflect across that line, we're going to count how far away our point M is from that line, and then we're going to go the same distance away on the other side. So I've got 1, 2, 3, 4, 5, 6. So then on the other side, 1, 2, 3, 4, 5, 6. Puts my point M prime right down here. And what would that ordered pair be? Negative 5, negative 10. M prime is negative 5, negative 10. Nicely done. All right. Let's flip this over to page 9, and we'll talk about some symmetry. Page 9, and a discussion about symmetry. Reflectional or line symmetry. If a figure has reflectional or line symmetry, then the figure can be folded across the line or axis of symmetry and be reflected onto itself. It cuts a figure perfectly in half. Cuts a figure perfectly in half. That means the two sides would have to be identical. All right. So let's look at some of these figures here and determine whether or not they have line symmetry. This smiley face right here, is there anywhere that I could draw a line that would cut the figure perfectly in half so that the two halves are identical? Yes. Can I take it and cut it that way and cut it perfectly in half? No. It cuts the circle perfectly in half, but it does not cut the smiley face in half. If I take this and I reflect the top on the bottom, do I have a set of eyes down here? Do I have a mouth up here? Then it is not being cut perfectly in half. Again, the circle is being cut in half, but we're looking at the whole figure, all of the shapes and stuff on there. So how could I draw that line then so that it would cut it perfectly in half so that if I folded it, the two sides landed on top of each other? Yes. From the top to the bottom, so I want to go in between the two eyes. Now if I fold it over, will one eye land on top of the other eye? Half the smile lands on top of the other half of the smile. Now this has been cut perfectly in half. We say this one has one line symmetry. For the letter E, can I do a vertical line again? Is there any line that I could draw that would cut it perfectly in half? Horizontal line. I would have to go right through that center part of the E. This one also has one line symmetry. There are no other lines that I could draw through the E to cut the E in half. And then I have my little hourglass here. Can I cut this one perfectly in half? Where can I draw my line? I can draw it vertically, absolutely. The left is identical to the right. And I can also draw this horizontally. The top is identical to the bottom if I fold the top down on top of the bottom. So this shape has two line symmetry. What about my triangle here? Do we have any lines of symmetry on the triangle? I can do vertical. Can I go horizontal? Can I do any other lines that would still cut it in half, even if it's not vertical or horizontal? Slanted, yeah. I can go through this corner and the halfway point over here. That would also cut it in half. Anything else? Yeah, I can go the other way. So how many lines of symmetry does my triangle have? 3 line symmetry. All right, now I have this big X shape. Does my X shape have symmetry? Where could I draw lines of symmetry on my X shape here? I can do vertical and horizontal. Vertical cuts it exactly in half. Horizontal cuts it exactly in half. Anything else? If I cut it right through one of these lines, could I fold it on top of itself? So there's 3 lines of symmetry. Any others? Yeah. I can go diagonally the other way. So how many lines of symmetry does my X have then? 4 line symmetry. What about the circle? What'd you say? Yep, we can go up and down. We can go vertically. We can go side to side. We can go horizontally. Can I do any other lines of symmetry on the circle? Can I go diagonally? Yeah, I can go diagonally this way or this way. Any other lines of symmetry? What about if I did this one? Would that work? Could I do this one? I can keep going with this, can't I? I have an infinite number of lines of symmetry here. Infinite lines of symmetry. What about the letter R over here? None. No lines of symmetry. No lines of symmetry on our letter R. Very well done. All right, so that is one type of symmetry, line symmetry or reflectional symmetry. You can think of it as folding on top of the other. We have another, another type of symmetry called rotational symmetry. With rotational symmetry, the figure can be rotated about its center onto itself. The figure is exactly the same after the rotation. The order of symmetry is the number of times a figure maps onto itself as it rotates from 0 degrees to 360 degrees. And then finally, before we practice with this type of symmetry, we still need to talk about magnitude of symmetry, or what we call the angle of rotation. This is the smallest angle through which a figure can be rotated so that it maps onto itself. The way we calculate the magnitude is we do 360 degrees divided by whatever the order is. So whatever we found for the order of symmetry, we will do 360 and divide it by that number to find the magnitude. All right, let's look at some shapes and see if we can determine the order and the magnitude for these figures for rotational symmetry. All right, so I have a Z shape. For symmetry, or for rotational symmetry specifically, I want to know whether or not it's possible to twist it about the origin so that it lands on top of itself. It maps on top of itself. So I am going to trace over my Z. When you guys are doing this on your own, if you want tracing paper, I'm more than happy to provide you with some tracing paper. So I can take this Z and I can start to rotate it around. It's not matching itself yet. Did it match? So I spun it halfway around and it landed on top of itself. If I keep going, it doesn't have that happen again until I get back to where I started. So we would say that this has order 2. Or we can say twofold. We could take this right here, rotate it down like this, and then rotate it back to where I started from. So my order is 2. That means my magnitude, which I'm going to abbreviate as just mag, we're going to take 360 degrees. We will divide it by the order. We will divide it by 2. So the magnitude would be 180 degrees. All right, what about this X shape? Do I have any rotational symmetry with this X shape? Let's say I'm going to take this corner right here is what I'm going to mark as my starting location. As I twist this direction, it's going to land on top of itself when I get right here, right? In fact, let's investigate this. I'm going to trace on top. And I'm going to rotate. Landed on top of itself right there. So there's a quarter of the way around. Can I keep going with my rotation? Can I get it to land on top of itself again? Yes. Going to rotate, 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 rotate. Lands on top of itself here. So that's 2. And then rotate, 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 rotate. Lands on top of itself here. And then to get back to where I started, rotate, 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 rotate. So how many times as I spun around in a complete circle did it land on top of itself? 4 times. So we say it has order 4. Or you can call this 4-fold rotational symmetry. I do not know why they use the word fold when they're talking about rotational symmetry, but you say it has order 4 or 4-fold rotational symmetry. And then our magnitude, we would do 360 divided by 4. What is 360 divided by 4? 90. So magnitude 90 degrees. My rectangle. Do I have any kind of rotational symmetry with my rectangle? Yep, let's trace around it. I'm going to mark the top of it so that I'll know when I get back to where I started. If I start rotating, it does not land on top of itself like this. But if I keep going, come on, pen. Looks like I didn't start right in the center, but it landed on top of itself like this, right? So I went halfway around, went down around like this, and then as I continue rotating, it lands back on top of itself right here. So what is my order here then? Order is 2, or 2-fold. What would the magnitude be? 180. We do 360 degrees divided by 2. So that would be a magnitude of 180. What is this shape? Octagon. How many times do you think I can rotate that around and have it land on top of itself? 8 times, absolutely. We can go 1, 2, 3, 4, 5, 6, 7, and 8. So order is 8, or 8-fold. And then the magnitude, we do 360 divided by 8. What is 360 divided by 8? 45. So the magnitude is 45 degrees. And then finally we have this heart shape. If I take my heart shape and I rotate it around, is there anywhere in my rotation before I get back to the beginning where it will land on top of itself perfectly? No. So do we have rotational symmetry on the heart? No. No rotational symmetry. No rotational symmetry. For regular polygons, you remember a regular polygon? This is all sides are congruent. All angles are congruent. A polygon is a shape with straight sides. So a square or an equilateral triangle or this octagon up here would be examples of regular polygons. So if I'm talking about a polygon with n sides, I don't know how many sides it has. It's any polygon. It could be 3 sides or 5 sides or 10 sides, 25 sides. We get n lines of symmetry. And our order would be n, or we could say n-fold, with magnitude 360 divided by n. So if I see a polygon, I see a shape where all the sides and angles are congruent. I know how many sides it has. That's how many lines of symmetry it will have. And the order will be 360 divided by the number of sides. Let's flip the page over and look at a couple examples where we look for line and rotational symmetry. Does my equilateral triangle have any lines of symmetry? We're on page 9. Or sorry, page 10. My apologies, page 10. So flip that page over. There you go. Does my equilateral triangle have any lines of symmetry? Is there anywhere that I could fold it that it would land on top of itself if I folded it over that line? There's 3. We can go vertically. We can go slantwise this way. We can go slantwise this way. So line symmetry, I'm going to say yes. We have 3 line symmetry. Do we have rotational symmetry at all? Yes. How many times, if I start up at the top here, how many times could I rotate this triangle around before I get back to the beginning where it lands on top of itself? Like how many stops can I make before I get back to the start? Well, if I rotate from this corner down to here, that'd be 1, right? Yep. And then this corner over here. If I do 2, then this star is going to end up here, and I'm not ending where I began. So we need 1 more. 3. So yes, we have rotational symmetry here with order 3, or you could say 3-fold. And then the magnitude would be 360 divided by 3, which would be how much? 120 for our magnitude. This figure kind of looks like my triangle over there, right? Do I have line symmetry with this? No. If I go vertically and I try to fold it over that line, this arrowhead is not mirrored over here. So the arrowheads don't land on top of each other. This right here is not an arrowhead, so that does not map. We have no line symmetry on this one. Anywhere I try to draw a line and fold it, it does not match perfectly across that folded line. Do we have any rotational symmetry though? Yes, we do have rotational symmetry. Let's see if we can find our rotational symmetry here. We're going to rotate around here. I'm going to put a star at the top so that I know where I'm starting from. Oops. Hold on just a second. I kind of messed this up a little bit, and I didn't mean to. Let's try that again. I'm trying to get just my shape to rotate. There we go. So I'm going to rotate it around. Right there. If my drawing had been better, it would be landing on top of itself right there. So there's 1. Yes, sir? It does not. Good question. Then I can continue rotating. Lands on top of itself there. Again, my drawing's only so good. And then we go back to where we started, right here. So I've got 1, 2, 3 for my order. 3 or 3-fold. So just like the previous problem, that means my magnitude is 360 divided by 3, or 120 degrees. Right. Now we have an arrow shape. Do I have any lines of symmetry for my arrow shape? Yes. Which way could I draw lines of symmetry so that I could fold it over that line and they would match up, Victor? Yep, we can go horizontally. We can go vertically. So yes, we have line symmetry. It is 2 line symmetry. Do we have rotational symmetry here? Yes, we do have rotational symmetry. So I need to count how many places I can stop, and it matches up perfectly as we go around this shape. So I'm going to do, that doesn't show up very well. Let's try this. There we go. So I'm just going to kind of trace over it here, starting from right here. I'm going to rotate this around. Lands on top of itself here. So I can come around this way. And then I can take it the other halfway around. It doesn't land on top of itself until I get back to where I started. So what is our order? 2. The order is 2 or twofold. So then the magnitude would be 360 divided by 2, which would be how much? 180. All right, big plus sign. Do we have any lines of symmetry here? With this big plus sign. Yes, we do have line symmetry. How many lines of symmetry can I draw? 4. We have 4 line symmetry. We can go vertically. We can go horizontally. We can go diagonally this way. And we can go diagonally this way. Do I have rotational symmetry at all? Yes. If I start right up here, I can take this side and rotate it here. That would give me my first stop, a quarter of the way around. Then I can rotate it down to the bottom. Rotate it back here. And end up at the top. So what is my order? 4. Which means my magnitude is 360 divided by 4. What is 360 divided by 4? 90. All right. We have 2 final shapes to look at. I have this flower shape. Do we have any line symmetry with this flower shape? Yes, we do have line symmetry with the flower shape. Let's see how many lines of symmetry we can draw in. I can go through the big pink petals, right? The large ones. I've got 1 line here, 1 line here, and 1 line here. So there's 3 lines. Can I draw in any other lines of symmetry? Yes. Yes. Yep, I can go through this. I can go horizontally. So I'm going through those darker pink petals. I can get 3 more lines of symmetry that way. So how many total lines of symmetry do I have? How many? 6. We have 6 line symmetry. Do we have rotational symmetry at all here? Yes. Yes, we do have rotational symmetry. So I'm going to pick this big pink petal right here to start with. I can rotate it around until it lands on top of this other big pink petal. That would be my first stopping location. I could keep rotating it until I get to the second big pink petal. Take it down to the third big pink petal. Keep rotating to the 4th, the 5th, and finally back where I started. How many times as I spin it can I stop and it matches before we get back to the beginning? 6. So we have order 6 or 6-fold. So my magnitude, 360 divided by 6, would give me what? 60. And finally, we have this parallelogram here on number 6. Do we have any line symmetry with the parallelogram? Yes. Where could I draw those lines? Can I go vertically? No. Can I go horizontally? No. So where can I draw my lines of symmetry? Through the corners. We can go corner to corner. Now if I fold it, this corner lands on top of this corner. Or I could go corner to corner the other way, because then this corner would land on top of this corner. So yes, we have line symmetry. How many lines? 2. We have 2 line symmetry. Do I have any rotational symmetry at all? Yes. If I start from say this corner right here, can I rotate it here and have it match up perfectly? No, this angle is a lot bigger than that angle, right? If I rotate it like that, here, let me see if I can trace around this and show you guys what happens. As I rotate, it'd be like this. Like that doesn't, no matter how I try to scoot it around to make up for the fact that I didn't do this well as I was rotating, I can't get it to land on top of itself. But if I keep rotating, that one matches. So I can go from this corner down here, and then I want to finish going all the way around to the beginning. So I'm going to rotate back until I get here, lands on top of itself. So yes, we have rotational symmetry. With what order? Order 2 or twofold. Which would give me what for my magnitude? 180. Nicely done. Very nicely done. In your packet, page 11 goes over the rules that we learned for reflections, translations, and rotations. If you want to look in one spot that has all the rules, you can either look at page 8 where we wrote them all down, or you can look on page 11. Your homework that you picked up yesterday is due tomorrow, or not tomorrow, sorry, Monday. Homework is due on Monday. If you need another copy, very bottom paper right here. Monday will also be the day of your second skills check in this module. So first we will grade your homework, and then we will take your skills check. You will get the review for the test, and the test is on Wednesday next week, the day before the PSAT.